let's talk about the valence shell electron pair repulsion theory.
The theory proposes geometric arrangement of terminal atoms or groups of atoms around a central atom in a covalent bond or charged ion. It is determined by repulsions between electron pairs present in the valence shell of the central atom.
Now we're going to talk about the different molecular shapes.
The linear shape model is nonpolar, which means it has symmetric distribution. Its bond angle is 180 degrees. It has 2 shared electron pairs but 0 lone electron pairs. Examples include carbon dioxide and beryllium hydride.
The trigonal planar has shared bond angles of 120 degrees. Some examples include boron trichloride and sulfite. They have 3 shared electron pairs and 0 lone electron pairs, and their polarity is dependent on the atoms involved in the bond. The tetrahedral molecular shape has bond angles of 109.5 degrees. It's nonpolar, meaning it's symmetric, and some examples are methane, ammonium, and phosphate. It has 4 shared electron pairs and 0 lone electron pairs.
The trigonal pyramidal model is polar, which means it is non-symmetrical. It has 3 shared electron pairs and 1 lone electron pair. It has less than 109.5 degrees for its bond angle. Examples include ammonia, nitrogen trifluoride, and phosphorus trichloride.
The bent molecular shape can be polar or nonpolar, depending on the atoms involved. It has a bond angle of less than 109.5 degrees, and they have 2 shared electron pairs and 1 lone electron pair. Examples are water, trioxygen, and nitrite. Now we're going to talk about molecular diagrams.
This is the trigonal bipyramidal diagram with its subsets. It's a molecular geometry with 1 atom at the center and 5 or more atoms at the corners. It is also characterized by having 5 bonds.
The octahedral diagram describes the shape of compounds with 6 atoms or groups of atoms symmetrically arranged around a central atom. Their bond angle is 90 degrees.
Now we're going to discuss polar versus nonpolar.
Polar is a covalent bond between 2 atoms where the electrons forming the bonds are unequally distributed. There's a positive and negative end, and it's water-soluble. Some examples are ammonia, sulfur dioxide, and hydrogen sulfide.
Nonpolar is a covalent bond in which the electrons are distributed more symmetrically and do not have different charges at opposite sides. They're fat-soluble, and some examples include neon, carbon dioxide, and methane.
These are the sources we used.
We hope you enjoyed our project!